All right, guys, welcome to this page of the notes. And what I want to quickly do here is take a look at a couple of example problems where what you're going to be doing is you'll be given a particular scenario, some sort of situation. You're going to be asked to write a polynomial that represents that particular scenario, and almost always these scenarios will be given to you in word problem format. So let's go ahead and jump right into these. You'll see exactly what you're being asked to do in the last statement here, which says write a polynomial to represent the distance driven. So we're going to be somehow in this word problem talking about the distance that you have driven. So here we go. The U.S. Department of Transportation limits the time a truck driver can work between periods of rest to 10 hours. All right, 10 hours. They can only drive 10 hours between taking breaks. All right, for the first part of a shift, Tom drives at a speed of 60 miles per hour. For the second part of a shift, he drives at a speed of 70 miles per hour. Write a polynomial to represent the distance driven. Okay, so here we go. We know that distance, simple physics formula, distance is equal to the rate or the speed, whatever, same thing. How fast are you going, your rate or your speed, times the time, right? So if you're driving at 50 miles per hour and you drive at 50 miles per hour for 1 hour, how far have you gone? Well, you've gone 50 miles, right? Because you were driving at 50 miles per hour and you went for 1 hour, 50 miles. If you're driving at 50 miles per hour for 2 hours, you've gone 100 miles, right? So this gives us the distance, which is what you were asked for, right? Write a polynomial to represent the distance driven. There it is, there's our distance. And the distance is given to us by the rate, how fast you're going, multiplied by the time. You guys should know that simple formula. Okay, well, let's break these down. I have a rate. Well, what was my initial rate? Well, they tell us right in the problem that I started off, Tom started off by driving 60 miles per hour. Okay, that was his rate. And how long did he drive at that speed? Well, they don't tell us. All they tell us is that he's limited by the U.S. Department of Transportation to 10 hours. He can only work 10 hours between taking when he has to take a break. Okay, so what we're going to then do, this is where the algebra comes in, is we're going to use t. We're going to make it a variable. In this case, we'll go and call it x, right? So he drove for X hours, however long that was. But then it changed, right? He then had a new rate after taking it says for the second part of his shift, he drove at 70 miles per hour. But I need another time, right? Well, okay, so he drove at 60 miles per hour for X hours, whatever that amount of time is. He then drove at 70 miles per hour for the second part of the shift, but again, they don't tell us how long that was, and I can't use X again because I already used X for up here, this part of his shift. Let me show you how this is going to work, and I'll do it here on a new page. Consider a football field. Down here at the ends, we have our end zones. We'll color them in. We have our uprights for kick and field goals. All right. This is a football field. All right, so let's see if I can even, maybe I can even get this. Let's see, there's midfield 50. All right, so I got to break these up into, yeah. Nice. Got it. So there's the 10, 20, 30, 40, there's the 50, and then 40, 30, 20, 10. Okay, great. So I got myself a football field. Now, here's what I want you guys to consider. All right? If you were to complete a pass, on the football field, and that pass was a 50-yard pass, how far do you have to go to get to the end zone? Well, the question is really simple. You still have 50 yards left to go. Let me explain to you the algebra that you're doing here. You know that the football field is 100 yards long. And if you completed a pass that is 50 yards. We just completed a 50-yard pass. How much further do you need to go? Well, you still need to go another 50 yards. Let me give you a trickier one. What if you complete, okay, let's say your O-line opens up a gaping hole you could drive a truck through, and you take off and run, I don't know, let's say 70 yards. Boom. All right, so you just 70-yard run straight down the sideline, tiptoeing down the sideline, then finally the safety pushes you out or something. You run 70 yards. How much further do you have to go to get to the end zone? Well, you know that the football field's 100 yards long. You just ripped off a 70-yard run. How much further do you have to go? Right, again, it's really easy to see. You have 30 yards left to go. Let's do some algebra. Punt return. Other team punts the ball to you. You are the return man. You catch the punt, take off down the field. You got a couple of good blocks. You make it to the sideline. All you got to do is beat the kicker. You don't. Embarrassing, whatever. We'll let it slide this time. So what you wind up with is, I don't know, let's give you a 40-yard return. But instead of 40 yards, right, all those numbers, it's raining really, really hard. All the numbers wash off the field. And so all you know is your return was X yards. X yards. Okay, so you don't actually know how far you returned it because, again, it's raining really hard. Everything got washed off the field. All you know is you had a return that was X. How much farther do you have to go to get to the end zone? Well, you know that the football field is 100 yards long. How much further do you need to go? Well, since you had a return that was X, you know that all you need to do is go the rest of the distance to get to the end zone. How far is that? Well, it's 100, right? Because it's a 100-yard football field minus the distance you've already gone on your punt return, which in this case is X. So 100 minus however far you return the punt, right? This would be the amount left to travel, or how far it is to the end zone. We'll call it the yards still needed. Right? How far do you have to go to get to the end zone? Well, simply take 100 yards, which is how far you've got to go, subtract how far you've already gone, and you'll know how much further you need to go to still get to the end zone. Let's take this back to the problem that we were just doing. You're allowed to drive for 10 hours. You've already driven X of those 10 hours. How much more time do you have to drive? Well, that's simply going to be 10 minus however long you've already been driving. So if you can drive for 10 hours and your first shift was 3 hours long, how many hours do you have left? Yeah, you've got 7 hours left. If it's a 10-hour shift and you've driven for 5 hours, how many hours do you have left? You've got 5 hours left for your second shift. But they don't tell us how long the first shift was, so we're going to use X, a variable. How do I figure out how long the second shift is? Well, take whatever the first shift is, subtract it from the total amount of time I'm allowed to drive. I know how long my second shift was. This is how we're going to take these problems, turn them into algebra problems, and now we simply use our formula, which is rate times time. So this guy right here is my shift 1. This is my shift 2. We're going to need to put all those guys together. So distance is equal to rate times time. 60 times X plus, right, my first shift, which was 60 times X, plus my second shift, which is 70 times X, or 10 minus X. I apologize, I'm squeezing there. Hopefully you can see that. 70 multiplied by 10 minus x. Distribute the 70, which is going to be, let's see, 700 minus 70x. Combine like terms. 60x minus 70x leaves me with negative 10x plus 700, and there is the polynomial representing the distance that I have driven. Again, the first part of my shift, 60 miles per hour. Second part of my shift, 70 miles per hour. The amount of time I spent driving in the first shift we call x. How long was my second shift? Well, it's the total time, 10 hours, minus however long I drove in the first shift, 10 minus x. Then it's rate times time, 60 times x, there's the first shift. 70 times 10 minus x, there's the second shift. Multiply it all out, combine like terms, got yourself your answer. I got another one for you here. Let's see how this one goes. All right, here's what you've got. Paul has $900 to invest in his savings account that has an annual interest rate of 1.8% and a money market account that pays 4.2% per year. Write a polynomial for the interest he will earn in 1 year if he invests X dollars into the savings account. All right, the equation that you need is the amount of money that he is going to earn is equal to the principal. It's a fancy financial term. Principal simply means the amount of money that you have invested. How much money do you put in to the account, right? The principal. And then you multiply that by the interest rate. So the amount of money you're going to make is equal to the principal times the rate, both of which we have. What is the principal? Well, in this case, the principal is $900. Oh, sorry. The principal. He's going to invest $900, but he's going to invest $900 into two accounts, into a, let's see, savings account and into a market account, right? So two different accounts, but they don't tell us how much he's going to put into each account, right? They don't say that. They just give us the total amount. Okay, no problem. Principal amount that goes into the first account we're going to call X. It has an interest rate. We don't do interest rates as percentages. You'll need to convert them to decimals, which means that you just take the decimal sign and move it 2 spots to the right. So 0.018. The second account, what is the principal? Well, the principal is going to be my total 900 minus however much I put into the savings account. Right? That's what's left. If I have $900 and I put 200 of it into the savings account, how much do I have left to put into the market account? Well, I got $700 left over. If I put 400 of it into the savings account, how much do I have left to put into the market account? Well, 900 minus 400 would be 500, right? You see the way that this works, so that they don't have to tell me how much I put into each account. I can just use algebra to figure it out. X, the total minus X. And again, my rate needs to be a decimal, so 0.042. All right, here we go. A is going to be equal to 0.018x plus 0.042 times 900 minus x. I apologize. Once again, I wound up having to squeeze. Distribute the 0.042 through the parentheses. And what you wind up with, if you use a calculator, you'll wind up with 37.8 minus 0.042x combined like terms, and you wind up with negative 0.024 x plus 37.8. Again, the directions said write a polynomial, which is exactly what I did. I wrote a polynomial showing Paul's investments into these two accounts And again, not knowing how much he put into each account, that's okay. Algebra can still deal with it no matter what amount he puts into each of those. Guys, thanks so much for joining me for this set of videos. I really enjoyed doing both review of the properties of exponents and looking at operations with polynomials, adding, subtracting, and multiplying polynomials. I'll see you guys next time.